We're given h of x is equal to negative 2 over x squared minus 1, which we're given is equal to 1 over 1 plus x plus 1 over 1 minus x. We want to represent this in terms of a power series and then find the interval of convergence. We know that 1 over 1 plus x is a sum from n equals 0 to infinity, negative 1 to the n times x to the n. And 1 over 1 minus x will be the same thing, except we don't include the negative 1 to the n. Now they both have the same index, so it starts from n equals 0 to infinity, so we can add them in together. So we have negative 1 to the n times x to the n plus x to the n. And now we can factor out the x to the n, and we'll get negative 1 to the n plus 1. Now, here we have to notice that when n is odd, negative 1 to the n is negative 1. So this whole thing is going to be 0 when n is odd. Therefore, we only care about the even numbers. Okay, so the even numbers is what is going to give us a number that is not 0, basically. Okay, so the even numbers will represent it as 2n. And when n is even, negative 1 to the n is just 1. So you'll have 1 plus 1 is going to be 2. So I can rewrite this as 2 in front times the sum from n equals 0 to infinity. And we're only interested in the even term, so that would be x to the 2n. Now we want to find the interval of convergence. So keep in mind, this is a geometric series with ratio. Well, it may not be obvious, but this is basically x squared raised to the nth power. Right, this is the same thing as x to the 2n. So the ratio here is x squared. And you want to make sure that x squared is between 1 and negative 1. So in other words, x would have to be between 1 and negative 1. Okay. Now we always need to check the endpoints. But this is a geometric series, and we know that we do not include the endpoints. So this would be the interval of convergence. Of x is equal to negative 1 over x plus 1 squared. And it says that this is the derivative of 1 over x plus 1. Okay, now for this, we're going to rewrite 1 over x plus 1 as the sum from n equals 0 to infinity of negative 1 to the n times x to the n. I'm going to bring the derivative inside, and I'm not going to worry about the negative 1 to the n, because the derivative does not change the sign. It's like if you're taking the derivative of x, you're not taking the derivative of the negative, because think of that as just a constant. You're not taking the derivative of negative 1, you're just taking the derivative of x and then multiplying by the constant. Okay, so then you'll just take the derivative of x to the n. And so this is just going to be negative 1 to the n times x to the n minus 1. And actually, because we took the derivative, this is going to go from 1 to infinity now. Okay, so this is our sum. And we want to find the interval of convergence. So for this, we have to use the ratio test. So that will just be negative 1 to the n plus 1 times n plus 1 times x to the n over negative 1 to the n times n times x to the n minus 1. So we want this thing to be less than 1 when we take the limit as n approaches infinity. So a lot of things will cancel here. We'll be left with a factor of negative 1. And because it's an absolute value, this is just going to be positive 1. and then we'll be left with a factor of x. So this x will come outside as an absolute value. So we have the limit as n approaches infinity, n plus 1 over n less than 1. Now this limit is obviously 1, so we'll have the absolute value of x be less than 1. In other words, x will be between -1 and 1. Now we need to test the endpoints. So first we'll look at x being equal to -1. So that would be the sum from n equals 0 to infinity. Sorry, n equals 1 to infinity. -1 to the n times n times -1 to the n minus 1. Simplifying this, we get sum from n equals 0 to infinity, -1 to the 2n minus 1 times n. If I take a limit as n approaches infinity, this does not go to 0. Therefore, it diverges. Similarly, we'll do the same thing for x equals 1. We'll have -1 to the n times -1 to the, positive 1 now, to the n minus 1. And then if we take the limit as n approaches infinity, this is not 0, therefore this is going to diverge. So we do not include the endpoints. So this is our interval convergence.